Okay, let's review what we have covered in this first chapter on foundations of economics, and let's look at some questions. And those questions are very similar to what you can expect also on the tests. So question 1, economics is best defined as A, the study of the use of scarce resources, the study of the use of scary resources, C, the study of the use of square resources, or all of the above are correct. Well, it's obviously the use of scarce resources. So who said economics is the science which studies human behavior as a relationship between ends and scarce means which have alternative uses? Was that A, Lionel Richie, B, Lionel Messi, C, Lionel Robbins, or none of the above? And of course that was Lionel Robbins, a professor at the London School of Economics. Okay, question 3. Emma stands in front of the vending machine and can hardly decide between a chocolate cookie for $1 or a vanilla cookie for $1. Eventually she decides to buy the chocolate cookie. What's the price she paid for the chocolate cookie in microeconomic terms? Is this $1, or is it the foregone vanilla cookie, or is it the foregone oatmeal raisin cookie, even though she doesn't like oatmeal raisin cookies? And the answer is, it is the foregone vanilla cookie. Because if she doesn't like oatmeal raisin cookies, even though they cost only $1, let's say, that's not an opportunity cost for her, because she doesn't get utility from an oatmeal raisin cookie. So the opportunity cost is always the cost of the next best alternative, and that is the vanilla cookie, not the oatmeal raisin cookie. Then we talked about money neutrality. What does that mean? A, whether we have money or not does not really matter for anything. B, a change in all prices, inflation, does not affect relative prices. Yeah, that sounds right. Both A and B are correct. No, because it's not A. It does matter. So it is B. Five, which of the following is not an explicit economic allocation system? A, the socialist central planning system? No. That is one, that's correct. The capitalist market system? Yeah, that is correct. The religious welfare system? No, that's not concerned with the 3 questions of economics: what to produce, how to produce, and how to distribute things. So it's C. Microeconomics is concerned with which of the following? A, household behavior? Yeah, that's correct. B, firm behavior? Yeah, that's correct. Different market forms like perfect competition and monopoly? So that is all of the above. So again, microeconomics is concerned with like the economic behavior for a single consumer, a single producer, or a single market. Okay, macroeconomics is concerned with which of the following? A, national unemployment? Yeah. Monetary policy? Yeah, that's correct. C, public debt? Also correct, so that's all of the above. The father of classical market economics is A, Adam Smith, B, Karl Marx, C, John Maynard Keynes, D, Alfred Marshall. That is Adam Smith. And here, next question, the father of modern macroeconomics is A, Adam Smith, B, Karl Marx, C, John Maynard Keynes, or D, Alfred Marshall. So that is Keynes. 10, the father of neoclassical economics, or micro, is Adam Smith. No, that's more the classical. Karl Marx. There's a typo. John Maynard Keynes. That's macro. Or Alfred Marshall. No, that is Alfred Marshall. So neoclassical economics is the new classical economics, and the new is the introduction of mathematical conceptualizations and formulas and graphs and such technologies. Okay, 11, the father of socialist economics is A. Adam Smith, B. Karl Marx. Yeah, obviously that's Karl Marx. Okay, 12, a distinct characteristic of neoclassical economic thinking is a distinct characteristic of neoclassical economic thinking is the Bolshevist revolution, the industrial revolution, the digital revolution, or the marginal revolution. So that is the marginal revolution. So we always think in terms of the utility of the next move, the opportunity cost of the next move, and that's why economics is sometimes called the marginal revolution or the marginal science. Okay, 13. You eat your favorite cookies. What can you say about the utility that you get from each extra bite? Okay, just think about being super hungry and craving a cookie, and now you have a cookie. So how does that feel, that first bite, compared to the, I don't know, third cookie, a fourth or fifth cookie? It starts out negative but increases? No. It starts out negative and gets worse? No. It starts out positive but gets less and less. Yet this is the law of diminishing marginal utility. It starts out positive and gets better and better with every slice or every bite. That can't be true, because that would contradict the idea that the more you consume, the less extra utility you get. Maybe I call that every bite. With every bite. Or every cookie. Okay, 14. Which of the following is a normative statement? We all should study more economics. The government should invest more on infrastructure. The central bank should raise interest rates. So those are all normative statements, because I say, or I imply, that all of these three examples, they are good in one way or the other. So whenever you read should, that's a pretty good indicator for a normative statement. So 15, which of the following is a positive statement? A, if the money supply grows faster than the real economy. Another typo. If the money supply grows faster than the real economy, inflation goes up. Yeah, that's true. If a firm can erect market entry barriers, society's welfare decreases. Yeah, that's also true. So both A and B are correct. So those are positive statements, because I'm not saying this is good or bad, I'm just saying that's the way it is. Okay. 16, what's a hypothesis? It's part of the scientific method. That's correct. It is an educated guess, typically stated as an if-then statement. That's correct. And so both A and B are correct. So again, if you remember, a hypothesis needs to be falsifiable. 17, the ceteris paribus clause means A, changing everything simultaneously? No. Changing one thing, holding everything else constant. Yeah, that is correct. changing everything, holding one thing constant? No. So very often in economic modeling, we ask the question, let's say, if you buy chocolate and vanilla cookies, and we try to explain how you allocate your budget towards the purchase of vanilla and chocolate cookies, then we assume certain prices. But now we want to know, let's say, what happens if the price for the chocolate cookie changes. But we hold everything else constant, your utility function and the price of the vanilla cookie. It doesn't make sense in economics to change everything at the same time. That makes things very, very complicated. And sometimes we just want to know what happens if one thing changes. 18. In economic theory, a hypothesis must be formulated such that it can be falsified. Be explained by deductive reasoning? No. Be explained by inductive reasoning? No. Be explained by logical reasoning? No. It must be falsifiable. That's the key element. And only because something is... So deductive reasoning means from the general to the specific. Inductive reasoning is from the specific to the general. Logical is logical could be dialectic, or there are several forms of logical reasoning. Like the most famous is all men are mortal. Socrates is a man, therefore Socrates is mortal. But for the scientific method, which rests on hypothesis testing, the key element is falsifiability. And inductive reasoning and deductive reasoning, that can be used in order to develop new hypotheses. Okay, 19. Which of the following is an economic production factor? A, labor, B, capital, C, land, all of the above. So that's obviously all of the above. And again, labor is unskilled labor. Land is arable land, but also fishery resources. And land and labor are readily available. Capital needs to be accumulated. And capital, that's very important, is not money or stocks of companies. Capital is real capital. Capital means that it is machines and factories and infrastructure, but it also can be good institutions like good courts, an independent central bank, a government that is no corrupt. That is all capital, but also human capital. But capital needs to be accumulated. Land and labor is readily available. Okay, so 20. Which of the following production factors need to be accumulated? Well, that's what I just said. That's capital. Okay, so here we see a graph. And in that graph, you have squares and dots. And so now the next question refers to this graph. So which symbol captures the marginal utility? Okay, so here on the x-axis we have cookies. So here we have cookies. And here we have total utility and marginal utility. So what did we say about the law of diminishing marginal utility? The more cookies you eat, let's say the first cookie that I have, that gives me like a utility of a lot, maybe like 4. That means for the first cookie I would pay up to $4. But then if I had a second cookie, I don't have the same level of craving anymore. So my willingness to pay goes down because my marginal utility goes down. So these black dots capture the marginal utility. Okay. So which symbol captures the total utility? So that would be this one here. So the first cookie gives me a total utility of 4. So that means if you move from no cookie to the first, the extra utility that you get is 4. Okay, but then if you have a second cookie, your total utility from consuming 2 cookies is now 7. And that's basically for the first one you were willing to pay 4, for the other one another 3, so you have accumulated already 7 units in utility. And you see the difference from the first to the second cookie. The second cookie increases your total utility from 4 to 7, and that corresponds to that marginal utility of 3. And then if you have the third cookie, having a third cookie increases your total utility from 7 to 9, but marginally only by 2. And if you have a fourth cookie, that means your total utility still goes up from 9 to 10, so the marginal utility is 1. And now you're really full, because even if you had a fifth cookie, you wouldn't get any utility out of it anymore. You are done with cookies, and so the marginal utility is 0. So the total utility is given by the squares. Okay, so if you had to fit a line matching the marginal utilities, which function, marginal utility, intercept, let's start with an intercept, plus minus the slope. Okay, what is the intercept here? If we fit a line, so let me see, I can fit here a ruler. So here I can fit a line. Okay, so obviously the intercept is 5 and the slope is -1. So the marginal utility is best described by 5 minus cookies, or if you prefer, minus cookies plus 5. So how big is the total utility when eating 3 cookies? Okay, when eating 3 cookies, total utility is 3, so that is 9. So at 3 we have a total utility of 9. How big is the incremental or marginal utility of the third cookie, which is the difference in total utility between the second and the third? Okay, so the third, the marginal utility is 2, which is an increase from 7 to 9. So the marginal utility is 2. How big is the incremental marginal utility of the fifth cookie, which is the difference in total utility between the fourth and the fifth cookie? I still remember that was the 0, because eating 4 cookies gives you a total utility of 10. Having a fifth cookie still has the same utility of 10, so the extra utility is 0. 27. Which cookie gives the individual the highest marginal utility? Well, that must be the first, because of the law of diminishing marginal utility. So moving from 0 to the first, that should make you the happiest. 28. A typical utility function is increasing at diminishing rates. That is correct. And again, if you draw a typical utility function, and you have a certain good, like cookies, a typical utility function looks something like this. And you see the slope of such a curve. This is the slope. Here the slope is very steep. And then the more you move to the right, the more you consume, the flatter gets the slope. And mathematically, the slope, the first derivative of a function, like a total utility function, the first derivative is the marginal utility. The first derivative of the production function is the marginal product. Okay, a typical production function is, so we talked about that also, a typical production function we have some input and we convert it into output. An input could be labor or capital or something. And then we said initially, if you have more and more input factors, people get super productive, so the output grows faster than the input. But then eventually you exhaust the specialization gains and output increases at diminishing returns. So that means initially you have something which we call economies of scale or specialization gains. You know, it's better to have 2 people in the kitchen and even better to have 3. But once you have like 10, 11, 12 people in your kitchen, you know, it becomes more and more difficult to produce more and more and more. So here we have in that first part, so here up to this point, here we have increasing returns to scale, and beginning from here, when the marginal output becomes again flatter and flatter, we have decreasing returns. Okay, so the marginal product function, okay, so we basically look at the slope. Initially slope is very flat, then the curve gets steeper and steeper, there's a maximum. So the marginal output input, marginal output. So the marginal output function must look something like this, which is an inversely U-shaped. So the production function is S-shaped and the marginal product function is like a flipped over U, inversely U-shaped. A typical cost function. So now let's still remember a typical cost function. So now when it comes to the cost function, we take the output on the x-axis and then we have here total cost. And then there is always some chunk which is fixed cost. But then on top of it we have something which is inversely U-shaped. So our typical cost function looks like this. So as more and more we produce, the cost increase at the lower rate than the output, because the workers that we hire, they become more and more productive, they realize their specialization gains, but they cost the same each worker, but they become more and more productive, so output grows faster than the cost. But then eventually we reach again a point of inflection and things go up. So if you compare that to the production function, it's like, yeah, a inversely S-shaped function. Okay, So for the next question, I'll just start a separate video because I also need to do something maybe again in Excel, and I don't want the videos to get too long anyhow. So I'll stop here and I see you in the next video. Thanks a lot.